हाय स्टूडेंट्स, वेलकम अगेन करता हूँ आपका चैप्टर नंबर 6 फिजिकल एंड केमिकल चेंजेस में. So in this chapter we are going to discuss first of all about the changes around us, and then we are going to classify these changes into two different types. One is physical change and another is chemical change. And then we are going to discuss about the difference in physical and chemical change. We are going to study the physical and chemical change by taking a lot of examples from our daily life and from the lab setups. So let's first of all talk about the changes around us. We see in our daily life we come across a lot of several changes. For example, we dissolve sugar in water, the crystals of sugar gets changed and it gets dissolved in water, and then we cannot see the crystal of sugar anymore. Similarly, during the formation of curd from milk, whole property of milk changes and it forms into new substance called curd. Same happens in the cooking of food as well, because cereal and pulses are very hot in the beginning, but after cooking whole taste gets changed, fragrance and color gets changed. Now there's example of cutting of piece of paper. When we cut the paper, its size gets reduced and its shape also changes. And when we stretch a piece of rubber band, then we see its length changes and its shape changes. So this is an example of change. And during the melting of ice, it gets melted and changed to liquid state. Physical state of substance gets changed. During melting of wax, solid wax gets changed into liquid wax. So during the boiling of water also we see that water which is in liquid state in the beginning changes its physical state and gets changed into gaseous state. And rusting of iron, a whole new substance rust get formed on the surface of iron, which is reddish brown in color. During burning of candle, heat energy and light energy get produced, which was not there in the beginning. During burning of wood also same happens. Heat energy, light energy, smoke, ash, whole lot of new substances get formed. And the same type of thing that we observe during burning of coal as well. Now all these changes, example of the changes that we have taken from our daily life, can be categorized or classified into two type of changes. One is physical change and another is chemical change. So broadly we can say the physical change is a change in which no new substance is formed, and in chemical change new substance is formed. Now we are going to discuss physical change first of all in detail. So in physical change, as I have already told, no new substance is formed, and I'll just take the examples now one by one. Cutting of piece of paper, like I was telling you, when we cut a piece of paper, its shape changes and its size changes, but the thing is the paper cutting do not give rise to formation of new substance. It is still a paper. So this is an example of physical change, and the change in property which takes place during the cutting of piece of paper is change in shape and its size. Similarly, when we stretch a piece of rubber band, then we see that its length gets increased, but the moment we remove the tension on the rubber band, it gains its original shape. So there is only change in shape and size, but no new substance is formed. So this is example of physical change. Beside, the process was reversible. Okay, the same is with the case of cutting of piece of paper also. We can stick these papers and bring it into its initial state. Now I'm taking the example of melting of ice. During melting of ice, ice changes its physical state from solid state and gets converted into liquid state. So there is only change in the physical state of water. So no new substance is formed. The formula of water in ice is also H2O, and formula of water in liquid state is also H2O. No new substance is formed. And the thing is that water formed upon melting can again be frozen back into ice or solid state. It means this is again a reversible process. So it clearly concludes, help us to conclude that in physical change, new substance is not formed. Besides, it is reversible in nature. Now I'm taking the example of boiling of water. When we boil water, the water changes its physical state from liquid state into gaseous state, and that vapor or the gaseous water can be converted back into liquid state upon cooling. It means this is also a physical change because no new substance is formed and the process is reversible. I hope you got. We can conclude that during physical change no new substance is formed and physical changes are reversible in nature. Now we are going to discuss about what are chemical changes. So in chemical changes, new substances are formed and processes are irreversible in nature. I will explain you by taking example one by one. So first of all, I am going to take example of rusting of iron. We see when rusting takes place on the iron, a reddish brown layer of rust get formed, and this rust is a totally new substance. The chemical name of rust is ferrous oxide. Okay, it is a ferric oxide. Okay, so this ferric oxide or the reddish brown layer on the iron was not there in the beginning, so new substances formed. That is why this is called as example of chemical change. Now I'm going to take example of burning of wood. What happens during burning of wood? Smoke is formed, flame is formed, heat energy is formed, and finally it gets converted into coal and ashes. So whole the process give rise to new substances. So burning of wood is also example of chemical change. Now I'm coming to next example is formation of curd from milk. When milk changes into curd, its taste, its texture and all its property gets changed. Curd is totally new substance, so formation of curd from milk is also example of chemical change. Now coming to the example of cooking of food, we see in the beginning cereal and pulses are very hard and there is no typical fragrance or neither they are tasty, easy to chew, but when we cook it, its color changes, its texture changes, its fragrance changes, and its taste changes. It means cooking of food is also an example of chemical change. And from all these examples, we found that during the chemical change, new substances are formed, heat and light energy is produced, sound may be produced, color may change, smell may change, and gas may be formed. Now I am going to take example from the laboratory. You see, when we take a strip of magnesium ribbon and heat it over a flame, then it combines with oxygen and burns with a white light, and this white light is extremely bright and finally it changes into white ash, which is called as magnesium oxide. And the chemical equation can be represented like this: Mg plus O2 give rise to MgO. Now when we dissolve this magnesium oxide in water, it forms a new substance called magnesium hydroxide. And in the solution of magnesium hydroxide, when we put red litmus paper, its color changes to blue. It shows that magnesium hydroxide is basic in nature. And we can write the formula: MgO, white ash of or magnesium oxide, plus water give rise to magnesium hydroxide. So in this process we see magnesium give rise to totally new substance called magnesium oxide, which upon dissolution in water give rise to totally new substance called magnesium hydroxide. So this proves that this is an example of chemical change. Now I'm taking another example: reaction between copper sulfate and iron. You see, copper sulfate is a blue colored crystal, and when we dissolve copper sulfate crystal in a beaker by adding few drops of dilute sulfuric acid, then blue colored liquid is formed. And when we drop a piece of nail or shaving blade into it and leave it for about half an hour or 1 hour, then we see on the surface of a blade or iron nail a layer of reddish brown layer of copper is formed, and the color of solution changes from blue to light green. How this change take place, this you can understand from following example or following reaction. You see, CuSO4 is the chemical formula of copper sulfate, and when we put iron nail in it, iron sulfate is formed. This is also called as ferrous sulfate, plus copper is formed. Now you can understand why the color of solution changes from blue to green, because iron is more reactive than the copper ions. So copper ions get displaced, that means iron take the place of copper, and copper sulfate get changed into iron sulfate, and the displaced copper get deposited on the surface of iron nail. That is why the color of iron nail or iron blade shows the deposition of reddish brown colored copper layer. So this is a special type of chemical reaction which we call displacement reaction in chemistry. So since whole new substance is formed, iron sulfate and copper, which was not there in the beginning, so this reaction between copper sulfate and iron is also an example of chemical change, and this process cannot be reversed back. So again, it signifies that chemical reactions or chemical changes are irreversible in nature. Now I am going to take example from daily life. You can take vinegar or sirka available in your home, and you add baking soda or baking powder in it. Then what happens? Gas bubbles are formed with a hissing sound. This gas which is formed is actually carbon dioxide, and we can represent this reaction like this: acetic acid plus baking soda, and its chemical name is sodium hydrogen carbonate. Upon reaction give rise to carbon dioxide. And since carbon dioxide is colorless, odorless, so in order to ensure that it is CO2 only, we have to pass this CO2 through lime water, And the property of lime water is that when CO2 is passed, its color turns milky. And why milky color is formed? Milky color is formed due to formation of calcium carbonate. So we can represent the reaction like this: CO2 plus calcium hydroxide give rise to calcium carbonate plus water. Now we see in all these two reaction, completely new substances are formed which was not there in the reactant side. So this is also a chemical change. Now I'm coming to example of rusting of iron. See, rusting causes lot of damage to the article made of iron, and rusting of iron occurs due to reaction between iron, oxygen and water, and rust is formed, and it is also called as iron oxide. Dear students, let me tell you, if oxygen is there and water is not there, then rusting won't take place. Similarly, if water is there but oxygen is not there, again rusting will not take place. It shows that in order to cause rusting of iron, both oxygen as well as moisture is required. And how rusting of iron can be prevented? This can be prevented by checking the contact between iron surface and oxygen and water. And how we can prevent this contact? By applying oil or by applying grease or by painting. And we can also coat layer of metal with more reactive metal like zinc or chromium. The process of coating a layer of zinc on the iron is called as galvanization. So what happens in galvanization? Now rusting of iron do not takes place, instead rusting of zinc takes place. Okay, so this is also called as sacrificial layering. Now I'm coming to another example, which is crystallization. So crystallization is process of obtaining large crystal of pure substance from its solution. See, this in the picture you see, this is the powdered crystal of copper sulphate, and suppose you want to convert it into beautiful large crystals of copper sulphate, then what we have to do? We have to dissolve it in a beaker, and then we have to add a drop of dilute sulfuric acid to it, then heat the water, and when water starts boiling, then and powdered copper sulphate is added slowly to it, and then we have to keep stirring the solution, and we have to keep adding the copper sulphate till no more powder can be dissolved. And when this state is achieved, then we have to filter the solution, allow it to cool, and upon cooling we see beautiful crystals of copper sulfates are formed at the bottom of container or beaker. You see the steps involved in crystallization. Step number 1 is dissolution. Step number 2 is heating. Step number 3 is filtration. And step number 4 is cooling and formation of crystal. Now this was a process of crystallization, and in crystallization no new substance is formed, so we cannot say that this is a chemical change. It's just a physical change. We have converted the like powdered copper sulphate into beautiful crystals of copper sulphate, but before and after the process of crystallization, the substance is still CuSO4 and 0.5 molecule of water, which is the formula of copper sulphate crystal. So no new substance is formed. So this is not a chemical change, this is just a physical change. So this was all about the various examples of physical and chemical change which you studied in this slide. I hope you enjoyed the video, and till you view my next video, I wish you best of study. Keep rocking. Thank you. Bye bye.